Hello, and today we're going to look at balancing a portfolio using recursion in Python. This is an example problem that you may see in a big tech interview. It is also a pragmatic problem in doing any kind of algorithmic trading of portfolio assets. In this example, we'll be using some sample data from 4 assets, each with a balance that they currently have, and a desired weight or ratio of how we want to have them redistributed. So one library we are going to use to load in this CSV data is Pandas, but this is not a Pandas tutorial. It's just very helpful for loading CSV data very quickly. We'll load the data like such. So we'll say portfolio goes pandas dot from read CSV. We'll pass in the path, data.portfolio CSV, and we'll indicate that this is a data frame. So just to quickly test that this works, we'll print portfolio df. And to test this, we'll run python main.py, and we'll see that we've loaded the data into our data frame. So the thing we may want to do is to name our columns so we don't have to keep memorizing the strings ahead of time. So call asset equal to asset, balance, and we'll add on call, keep our terminal open, equal to balance, weight, is going to be weight. And now we're going to add 2 new columns. So our normalized weights will be just weight norm. And we'll use that to compute new balances. And then new balance. So our next step is to compute the actual desired balance. So to do that, you're going to first get our weighted norms, norm weight column, and all this is the portfolio weights divided by the sum of those weights. And this will make sure that the weights all add up to 1. And then finally, the new balance column is equal to portfolio balance summed up, and then multiplied by the new weights. Finally, print our portfolio data frame to check our results. And we can see new balances distributed accordingly. All right, so after that, what we'll want to do, say, I'm going to want to transform this data into something a little bit easier for a function to deal with. To do that, we're going to use a little helper tool called namedtuple. And our namedtuple is going to be a brand new variable. So we'll just call this, let's see, portfolio record, or asset record, that'd be better. And this thing's going to have 3 fields. It's going to have balance. It's going to have new balance. And then it's going to have the name of the asset. Right, from there, what we'll want to do Let's convert our data frame data into these asset records. So to do that, we're going to iterate over the rows as such, using iter rows. And then what we're going to do is convert into record. We'll have asset records, just a list. And this will be where the asset records will have asset is equal to portfolio row, asset call, balance is going to be the portfolio row, balance call, and finally new balance, portfolio row, new balance call. And as the last step, we're going to append this record. So next, let's print out these asset records. To verify that that worked. And it did. So now we can start working on our recursive function. And this will do the meat and potatoes of our code. So all this function is going to do is get trade, and it's going to look at a list of assets, list of asset records, and this is just a helper. So what we want this function to do is to identify the trade for a given set of assets, one trade that'll reduce the biggest difference between the balance and the new balances. So here we want to order our assets, sorted, our existing assets, and then we're going to sort. So for a given asset record, we want to use the balance is a dot new balance. All right. And what this will be, let's quickly test this. Asset records. Right. And we should see that the biggest difference is up here. Now we may want to use reverse equals true, because we want to sort from the currency we want to move out of the most to the currency we want to pull money into. Try that again. And this makes sense, because USD, we want to have none of it, so you want to transfer it into the other assets. And as for BTC, it's lower than what we want, so we want to transfer as much into this asset. Let's do this. All right. So to compute our trade, we're going to want to look at two things. we're going to have an ingress asset and an egress asset. Our egress asset is going to be the first asset in this list, and it's the money we're going to want to move money out of. Our ingress is where we're going to want to move assets into. So to do this, we'll have our egress, and this will be the first one. So we'll want to know the egress difference between the balance and the new balance. Equals assets 0 and for simplicity we'll let this know that this is a list of assets dot balance minus assets record 0 dot new balance. Not asset record, just asset. New balance. In fact, I can probably clean this up. Delta is given an asset, which is of type asset record. Return asset dot balance minus asset dot new balance. And what we're going to want to do, say get asset delta of asset A. What we're going to do is say get asset delta of our first assets and our ingress delta. Let's get asset delta of the very last asset in this sorted list. And then our trade is going to be the minimum of these two. Delta, ingress delta, and ingress delta, I'm going to take that. And we want to print our trade amount. Call this trade amount. And if you were to run this, you'll see we want to transfer 200 of USD to BTC. And that makes sense if we spot check that. 200, that'll be 241, which is still less than the desired new balance. So now we will want to address our base case, which is if the trade amount is not worth registering the trade. So to do that, we want to get the sum of the assets. So if we look at assets, and to do this, we'll say, so for asset A, we'll want to get the A dot balance. This will be total balance, and if trade amount less than 0.1% times total balance, then we'll just return the fact that we don't want to have any, we have no trade to register. And this will return a list. This is saying, okay, we looked at our balances and there's nothing to trade, which in our example at this point, there's still stuff to trade. So now we're going to want to register a new data structure called trade record. I'm going to call this trade record. I'm going to call it from asset to asset amount. And our goal is to get a list of these trade records. So here, we're going to create a new trade record. Is equal to, and our from is our egress asset. So it'll be assets 0 dot asset. So from asset is this. To asset is this. And this will be the last asset. And then the amount is equal to the trade amount that we just computed. And we will want to return this, a list of this trade. And trades is equal to this. And we'll want to, at the end, print our list of trades. Let's test this code. And we're going to want to trade, so register the trade from USD to BTC for 200 in our base denomination. So next we'll want to apply our trades. So we can do this right here, but to keep the code clean, let's create a new function called def apply trade. We'll have our assets, that is a list of asset record. Then we'll have our trade, which is a trade record. And this is going to return a new list of asset record. And let's put this 1 line. So right here, what we're going to want to do is say, okay, from ID to ID. Actually, we don't want to do that because our trade record has the ingress and egress in it. So new assets is going to be a new list that we're going to want to return. I'm going to iterate over assets and create this new asset. This is going to be asset record. And now the asset record is going to be named after the old asset. The new balance is going to be call this old assets. Keep things simple. The balance, the new desired balances don't change because it's a target. However, the one thing that does change is the balance itself. New balance, which we have not computed yet. So if our old asset name is equal to the trade from asset, we're going to want to pull the money out of the old asset account. So old asset dot, so new balance is equal to old asset dot balance minus trade dot amount. Else, or else if old asset is the trade to assets, so we're putting money into this trade. The new balance for this trade is going to be old asset at balance plus trade amount. And the other cases, we're not doing any trades for this asset yet. So new balance is just the old asset balance. Dot old asset balance. And then now we're going to add this in. Our new asset. and then return new assets. So this will apply the trades. And we want to say our adjusted assets equals apply trade to our existing assets and the new trade. And for now, we're going to print and test this. So let's test this. All right. So we see that we moved all the money out of USD and that we put it into BTC. So that worked. All right. And next is going to be our recursion step. So now we want to get trade. So we'll call our next trades. Let's get trade of the adjusted assets. And we'll return the concatenated list. And this may or may not fail. Let's clear this up. And we have a list of trades. And finally, so we want to trade from USD to PDC 200, from ETC to Algo 23.7, and from ETC to BTC 8. And as a final step, let's just print here, because this is our last case of our assets. Let's try this again. And as we can see, so we look at our first asset, our balance equals the new balance, balance equals the new balance, balance equals the new balance. And our final results are the list of trades from largest transaction to smallest that will satisfy the new balance according to the weights we specified. So next, we want to save this data. So now that we have this, so we'll want to create a trade df data frame from records. And this will be a list of dictionaries. So say, we'll just map what is our structure from asset to asset. To asset. And then amount. And right now we're going to list for trade in trades dot from asset trade dot to asset and trade dot amount. And we'll just clear this up. Now let's test this data frame. All right. And now let's save this data frame. TCSV. We'll call this data trades. Index equals false. Let's run this again. Let's also get rid of this print statement. And look at our computed trades. And so now running this script, we'll look at this file, look at the input balances, look at the weights that we want to rebalance our portfolio, and it'll tell us the list of trades in order that'll quickly rebalance it using the least amount of steps. All right, that finishes this tutorial. Have fun coding.